Hi everyone, we'll be waiting 2 to 3 minutes before starting the webinar to accommodate for the rest of the attendees who are in the middle of connecting. Welcome everyone, thanks for joining us and thanks for being part of our community. My name is Valen Kolika and I'll be your host for today. A few reminders before we start. If you have issues viewing the stream at any time during the presentation and are using the web browser version of Teams, please refresh your browser. If you're using the desktop app of Teams, please exit and rejoin. Please note that this webinar is being recorded and will be shared publicly. We will post the recordings on our community at aka.ms/security-webinars. And all the links that I'll be mentioning, they're already posted on your IM window. Closed captions are available during the live broadcast. You can enable it by clicking on the CC button located at the lower right corner of your screen. During this time, please feel free to ask questions at any time by typing them in the live event Q&A window by clicking on the Ask a Question button. Be aware that any questions you post will be publicly visible. However, if you prefer, you can post your questions anonymously by checking the box right below where you enter it. Now, we often get many questions on these webinars, and we will do our best to respond to all of them in real time. In the event if the answer was not provided, or if you may have additional questions post this event, please don't hesitate to raise them on the Microsoft Security and Compliance Forum at https://aka.ms Security Compliance. If you're listening to this after the fact as a recording, that's also a great place to ask a question. We love to hear your feedback on how we can improve these webinars, and you can do so at aka.ms/security-webinar-feedback. And while you're there, please join our community by visiting aka.ms/security-community. That's the best way to ensure that you don't miss any future webinars or major announcements. In our community, you can speak directly to our engineering teams that create and our security products, and you'll be able to influence our product designs and get early access to changes by doing things like participating in private previews, which you can sign up for that at aka.ms/security private preview. And while you're there, you can request features, you can give feedbacks, review our product roadmaps, attend in-person events, hopefully soon. We'll get back to normal to do that, and join our webinars like this. We believe that the best way to improve our products is by removing any barriers between you and the people that create them. So we hope you'll join us. Today, Phil and Joe will take us over the MITRE ATT&CK for ICS. Phil Nere is a VP of IoT and Industrial Cybersecurity. And Joe DiPietro is a VP of Customer Cyber Success, both with our CyberX team. And without further ado, I'll turn it over to them. Phil, Joe, the floor is yours.
Thank you, Valone, and welcome everyone to our webinar today. Pleased to have my friend and colleague Joe on the call. Joe has a lot of experience with our customers, and we'll be going into a deep dive, and I'll be starting with a quick intro. Some of you may be new to OT security or operational technology security, so I'm going to do a quick intro into some of the differences. You're going to see there are differences, such as specialized protocols in OT, but there are also lots of similarities, such as the attacker kill chain. I'm going to do a quick intro into what is the CyberX technology and how it's being integrated into the Microsoft security portfolio. And I'm going to hand it off to Joe to do a deep dive into the MITRE ATT&CK for ICS framework. He's going to use a couple of examples, the Triton attack on a petrochemical facility, as well as NotPetya, and then he's going to show how you would investigate those in Sentinel, and then do a live demo of CyberX. And then I'm going to end up with some links for more information. So let's talk about what is OT security, and this is the definition that Gartner uses. The basic difference is that IT security is concerned with protecting digital assets like SQL Server databases and containers, whereas OT security is focused on securing physical assets like turbines and mixing tanks and HVAC systems in building automation systems. And that leads to a number of other differences. The first is that OT security is primarily focused on safety, protecting the employees, protecting the company's assets from incidents, and as well as availability, keeping the plants running and producing what they're designed to produce. We've talked about the specialized protocols. You may have heard about some of them: Modbus, DNP3, Siemens S7. The devices also tend to be different. They're embedded IoT and OT devices, but we also find Windows systems in these environments, but they tend to be legacy platforms like Windows XP. More than 2/3 of the sites that we've assessed are still running older versions of Windows that are no longer receiving patches from Microsoft. So that adds additional vulnerabilities to the environment. They've traditionally been air-gapped, separated from both the internet and the IT network. That is changing in the last few years with digital transformation and Industry 4.0. We're seeing more connectivity, and that's increasing the attack surface and making it easier for adversaries to get in. But the biggest difference is that on the IT environment, we have 10 to 15 years of experience putting in telemetry and controls to be quickly notified if something unusual is going on in the environment. Whereas in the OT environment, there is little or no visibility into the risk or if there are any threats in the environment right now. And that directly translates into business risk. And there's three kinds of business risk I want to talk about here today. The first is financial. When ransomware shuts down a plant, or destructive malware, as in the case of NotPetya, shuts down a plant, that causes losses in the hundreds of millions of dollars for that organization. And so you can see how this is a key focus for boards of directors concerned about, can this happen to us? With WannaCry, we saw automobile plants being shut down. With NotPetya, we saw large pharmaceutical companies being shut down for months at a time. Locargoga just last year, and ECANS, which is snake smell backwards, it's a type of malware specifically focused on shutting down industrial control system processes. The second major business risk is loss of sensitive IP. We usually think of that as being stored on the IT network, but much of the information about proprietary manufacturing processes are actually stored on the OT network. And here's an example that was discovered last year by the Microsoft security research team, where they found Strontium, a nation-state adversary, compromising internet-connected devices that still have their default credentials, using that as a launching point into the corporate network. The very first thing the adversary did when they installed their malware on these devices was scan the network to see what was available and what else they could compromise as part of the kill chain. And IP theft is particularly important for manufacturers. This is from the most recent DBIR, where manufacturing companies are 8 times more likely to be breached for theft of sensitive IP than any other vertical. The third major business risk is a safety risk. And here I want to introduce Triton. We're going to go into a little more detail when we get to Joe. So what was different about Triton was it was going after the safety controllers in a plant. Safety controllers are used to shut down the plant when unsafe conditions are reached, such as the pressure or the temperature in a tank going above a certain threshold. And the adversary was looking to compromise those safety controllers with the goal of causing damage to the plant and also loss of human life. We're going to go through the kill chain here. So what you're going to see in this kill chain, number one, is that it looks a lot like a kill chain that you would see on the IT network, with an initial compromise followed by privilege escalation and pivoting. But you're also going to see some differences in that the adversary was leveraging deep knowledge about ICS, or industrial control system protocols, to compromise the devices. And what you're also seeing here is what's called the Purdue model, which is the way industrial control folks look at their networks. And everything to the left of that blue line is the IT network, everything to the right is the OT network, and then there's 5 levels along the way. So the adversary first got into the network through most likely a phishing attack. We don't know exactly how they got in, but that's what is the case in the vast majority of situations. And they used that initial malware on that person's workstation to steal credentials, enabling them to get remote access into the OT network. This is very common because if you're a control system engineer, you're sitting on your, in your office or at home, you're not sitting on the OT network, you're sitting on the IT network, but you may need to get access to systems on the OT network using remote protocols. And so in this case, they got to an engineering workstation, which is a Windows-based system that control engineers use to reprogram controllers. They installed their malware there. It turned out to be Python compiled as a Windows executable. And here's the interesting part. The first thing they did was scan the network to see what devices were out there. And when they understood which devices were out there, they built purpose-built malware that understood exactly how that safety controller was configured, and that they were able to speak directly to that controller using its native proprietary protocol, which is called the Tri-Station protocol. They installed a backdoor first into the user space of that PLC, but then they moved it into the firmware memory region, which is very clever, allowing the PLC to keep continuing as normal, but they had their malware in there, and it was in the firmware region so that it would be persistent. And so their goal was to disable that PLC and then launch a second cyber attack that would cause major damage to the plant. Now, had there been telemetry in this environment, it would have been detected at a number of different places. The first was that first scanning that occurred. We saw that also in the IoT device example that Microsoft Security Research discovered last year. It's a very common tactic. And then we would have seen it also. This is the equivalent of living off the land tactic, but applied to OT. So control engineers from time to time will update the programs in these PLCs, programmable logic controllers. But in this case, the attacker used a standard command, PLC program update, to load their malware into that system. So it would definitely require investigation as a suspicious activity. So why is behavioral anomaly detection required today compared to using static IOCs? It's because of these living off the land tactics. You can see here that more than half of attacks last year were accomplished using, known malware, but using living off the land tactics such as stolen credentials and PowerShell. And for most organizations, their goal becomes not preventing all of the initial intrusions, because you know that a determined adversary will eventually get into your network. It's more about detecting that intrusion as quickly as possible so you can mitigate the attack before it causes damage to your plant or to your people. So let's talk about the CyberX technology for a second. So it's agentless security for unmanaged devices. Unmanaged devices are all of these OT devices that were never designed to support agents. And so the very first thing that people want to know is, what devices do I have? How are they communicating with each other? How is the network configured? And for many of these organizations, getting this visibility is the first time they're really getting a peek into what's in their network. So today it's a black box for most IT organizations. They come and they say, hey, what devices do you have? And nobody really knows. The second major capability is understanding the vulnerabilities in the environment. That could be everything from unpatched systems to unauthorized connections to the internet, devices calling home that nobody knew about, unauthorized devices themselves that were connected to the network without telling anybody, connections between IT and OT that no one knows about. It really should only go through a single DMZ connection, but often people will connect ad hoc connections between IT and OT that no one knows about. But the key here is focusing on the mitigations to the crown jewel assets. You can't fix everything, you can't patch everything. So how do you prioritize based on risk so that you're protecting your most important assets and processes? And then finally, continuous monitoring, as well as how do you do threat hunting, how do you do incident response, so you can very quickly mitigate any threats that are detected in your environment. The fourth one is related to operational efficiency rather than to cyber value, which is when a piece of equipment starts malfunctioning or is misconfigured, for example, is blasting out packets across the network because somebody misconfigured it, that'll cause efficiency issues in the OT environment. It'll cause the plant to be less efficient. And so the control engineers are very happy to have this new visibility they never had before, so they can very quickly figure out which is that device that's blasting packets across the network and how do we quickly configure it correctly. And then finally, for many years, there have been silos between IT and OT. On the technology side, there have been silos, but also on the organizational side. And so a big value here is breaking down those silos and bringing information into the SOC so that you can use the existing security stack, the SIMs you have there, you can use the workflows you have there. Certainly the workflows need to be modified in some cases to adapt to the unique characteristics of OT, but you're not going to build a whole separate SOC to address incidents in the OT environment. You want to train the folks in the SOC to be able to handle those environments using the workflows and the playbooks they already have. And then from a compliance and governance point of view, the auditors want to know that you have a unified view across IT and OT. They don't want OT to be a black box from the CISO's point of view. And how does this technology be deployed? It uses something called passive monitoring or network traffic analysis, where you connect to a span port on a network switch. You can also connect to a tap and then capture a copy of the traffic and analyze it using an on-premises sensor, which can be a virtual or a physical appliance. In the case of CyberX, we use that doing deep packet inspection, and it goes up to layer 7, analyzing the payload and all of the other header and metadata information using very specific OT-aware behavioral analytics. The idea here is to analyze that traffic so you can detect threats as quickly as possible with minimal false positives and with a fast learning period. And that's where the patent comes in. CyberX is the only company to have behavioral analytics algorithms that are specifically designed for OT using something called finite state machine modeling, which is based on a deterministic model of the network. If you try applying other types of behavioral analytics that were designed for IT networks, they're going to take a long time to learn the network, and you're going to get a lot of false positives because OT networks are very different in their behavior, being much more deterministic. So that analysis leads to information about assets, vulnerabilities, and threats, which are then displayed in a console, which can be either on-premises or cloud, and then passed on to your SOC and your SIM, whether that's Sentinel or Splunk or other systems that you may already have in your environment. So the important part here is that there's zero performance impact. There's no active scanning of the network. There's no agents being installed on devices. It's using something called passive monitoring, which is not in line. It captures a copy of the traffic and then analyzes it. The other thing is that this deployment is available 100% on premises and will continue to be so as part of Microsoft, or you can use the cloud connected capabilities that we will be developing as part of Microsoft. And just finally, before I hand it off to Joe, how does this support the NIST CSF? Well, in terms of the identity part of the CSF, it's understanding the assets, the topology, any unauthorized remote access and credentials. In terms of the prevention part, it's doing something called threat modeling that we're going to show you. It's mitigating threats. We also have native integration with firewalls and NACs to block the source of malicious traffic. And that can also be handled through Azure Sentinel's SOAR capabilities, automated playbooks. And the detection, we've talked about detecting anomalous activities or unauthorized activities, leveraging threat intelligence feeds from our in-house Section 52 team, which monitors OT malware campaigns and adversaries, and that information gets fed into the platform as well. The response part we've talked about, investigations and response, and then the recovery part as well. And now I'd like to hand it off to Joe, who's going to do, how does this fit into Microsoft's security portfolio? So the CyberX technology is being integrated into an existing product that Microsoft has called Azure Security Center for IoT. That Azure Security Center family includes capabilities for monitoring cloud workloads like SQL databases and containers. And also, we're being integrated with Azure Sentinel, which is the industry's first cloud-native SIM source system. And now I'd like to hand it off to Joe, who's going to talk about MITRE ATT&CK and do a deep dive. Joe?
Super. Thanks, Rick. Let me share my screen. Hopefully, you guys can see that now. So for the technical portion of the presentation, we'll do a short background on industrial control system. Then we'll talk about the MITRE ICS framework. And then we'll use the framework to hopefully give you some pointers on improving your ICS security posture. We'll do a live demo, we'll talk through NotPetya and Triton, and then give you a summary and recommendations. So if we go to a little bit of a networking background, essentially, everybody's probably familiar with IT networking and things like that. And if we look at the enterprise network down here, it's comprised of a number of different things. And the core switch, some distribution switches, UTM and firewall, and then routers out to the internet. And when we look at the network from an operational technology or a plant engineering perspective, they use something called the Purdue model. And they take this portion of the network, the enterprise network, and they label it levels 4 or 5. And you can see the distinction between the IT portion of the network and the OT portion of the network. And typically there'll be a firewall or DMZ that's associated with it. And you have level 3 according to the Purdue model. When you have your supervisory components, they're at level 2. All the process control and the field control will be down at levels 1 and 0 respectively. So this portion of the OT network is the operational technology. And you may hear different terms like industrial Internet of Things or IoT or industrial control systems or SCADA. These are different terms that are referring to the OT network. And one thing, as we start to, companies are getting more and more alignment of IT and OT, it's really critical for operational success. And these groups need to work together in order to have a successful integration and get visibility from a security perspective as well as operational. And one of the biggest elements is to understand the boundaries, organizational boundaries, in order to help each other across that chasm. And from this perspective, I'm going to go over just a couple basic components within the industrial control system, or ICS components. The first one is a programmable logic controller. And essentially, the PLC receives information from the connected sensors or input devices, and they process that data, and then they trigger outputs based on pre-programmed parameters. So you may open a valve, for example, to have cooling water come in and cool a certain component, or you may shut a valve, right, because you want the system to get warm and so forth. And there's a number of different vendors, ABB, Allen Bradley, Siemens, Honeywell, Motorola, Hitachi, and so forth. The next component is a remote terminal unit. And these types of devices are very similar to PLCs in function, but they can cover a wider different geography. So they may need to be spread out a little bit further. And you can see some of the vendors here that are very common with RTU components. The next component within an ICS system is the HMI, or human machine interface. And basically what this does is we need all of these physical processes to be human readable. And so you can see over here where the plant is at a certain state, and maybe the temperature is at a certain ratio right here. So we have a human machine interface to graphically represent all of the different forms and processes that are occurring at the plant. And then when you have to program the different components of the PLCs, RTUs, the engineering workstation, the EWS, is responsible for that, right? And it's responsible for the configuration, the maintenance, the diagnostics of the application. And what you see down here is the ladder logic that's associated with that. So the engineering workstation programs ladder logic that gets pushed to the PLCs that perform their specific function. And lastly, there's a historian, and these are the majority of the components. There's others as well, but the historian is responsible to capture all of the data and look at it from a historical perspective so that you could see how to improve part of the processes and procedures that, and if there's a device that's malfunctioning, what's going on with that device and so forth. So if we take a look at the MITRE ATT&CK framework and we put in the different components, at the field control level, you see the actuators and the sensors and so forth. At the process control at level 1, you see the RTUs and the PLCs. And then you see the engineering workstations, the HMIs, historians at level 2. And MITRE has two different frameworks. They have the enterprise framework, as you see right here. And this is responsible for, remember that enterprise network that we identified earlier. And they've recently released the industrial control system attack framework. And that's the one that we're going to be doing a little bit more of details in this session. So MITRE ATT&CK framework for ICS. It has very specific information on the tactics, techniques, and procedures, the TTPs associated with it. They have 11 different tactics, and they range from the initial access, discovering some information, collecting information on the environment, doing lateral movement, and then trying to evade monitoring solutions, for command and control to be able to, as Phil mentioned earlier in the Triton attack, to be able to reprogram PLCs, to execute different components. They're going to be living in there and try to be persistent within your environment. And then what kind of impact do they have, as well as impairing process control functions and inhibit response functions. So these are the 11 tactics, and this provides us a common language that we can use from a security operations perspective with our red team and blue team to identify where in the environment are part of the perpetrators. And then under these 11 tactics, there's 81 techniques associated with them. And this is what we call the techniques matrix. And you can see here the 11 different tactics that are associated with it. And on the link, MITRE also identifies different software. So if you look at a couple of different software like Triton and NotPetya, these are two examples that we'll look at in detail. But on the MITRE ATT&CK framework, they'll give you the different technique matrices that they used in order to compromise the environment. And then there's also adversary groups associated with that, and then the assets that are presented. Now, we have the 11 tactics, and what I want to do is kind of break them down into a specific timeline. So these are 3 of the different tactics, and according to the timeline, this will be very early in a breach, right? So initially, they're trying to get initial access into your environment, and this is where the lights are turned on, right? So how do we get our first foothold in the door? From there, they're trying to discover information, what ports and protocols are used. They'll look at collections, right? Identifying, oh, this is a certain type of device, and try to organize them. And in the case of Triton, right, where they did the port scan, they're trying to figure out what protocols are associated with that. And when you do the next phase of lateral movement, evasion, and command and control, you're looking at how the networks are built. And essentially what I want to do now is I want to show you a little bit of the CyberX solution. So if I look at the CyberX system, let me log in. You can see I have 3 assets on the map. And what I want to do is discover. So what we typically do is we're passively connected onto the network. And so I want to play some PCAPs. And what this will simulate is network traffic that's being generated. And this is all of what CyberX, you can see the PCAPs starting to send their information right now. And this will help discover different components on the networks, right? And you can see the packets per second, and alerts are going up, and some assets will be built. So I'm going to come back to that in a second. But this is what is happening from a timeline perspective, is understanding how the systems are connected. They're doing lateral movement, evasion, command and control. And then once they get their foothold, they know what they want to do. They're going to have execution and persistence, right? And this is the hard part, because they're trying to evade all of the different monitoring solutions that are in the environment so they don't trip alerts and events. And when they get down into the later stages here of impact, impair process control, and inhibit response functions, one little element over here can go a long way. It's a really big ripple within the environment once they hit those stages. So you want to identify very early in the cycle where the attackers are coming in before they get a chance to really impact your environment. So if you look at the kill chain from a MITRE tactics perspective, I know we have a lot of IT people on the phone. So this is an example of a IT kill chain, right? Where you have reconnaissance going on, and then you're trying to weaponize that information, and then you have to deliver it into the environment. And you can see these 3 aspects are very similar to the initial access, discovery, and collection portion of it. Then when you're starting to do exploitation and installation, you're starting to do your command and control and trying to be persistent within that environment, as well as doing actions on your objectives. That comes down into this area of the MITRE framework. So hopefully that is a little helpful, that you see a little bit of how they relate to each other. And here's a quick timeline of growing threats to IoT and OT infrastructure, right? Stuxnet was probably the first well-known one where we destroyed centrifuges. And what happened was, in the HMI system, they made it appear like everything was normal, right? But when in fact the centrifuges were spinning out of control. You see black energy in the Ukrainian electrical grid contact. And then you also have in 2016 Indestroyer in Mariah with distributed denial of service attack. And then we have NotPetya and WannaCry in 2017, as well as Eternal Blue was stolen from NSA. And then Triton was a very popular petrochemical facility attack in 2018. And then Locker Gogar and Microsoft finds IoT campaign with voice over IP and printers and so forth. So you have a history. So now let's kind of dive into a simple example with NotPetya and how that will map into the MITRE framework. So within the MITRE framework for NotPetya, you can see that they used a couple of different techniques that were used. And this is using external remote services. So what are some examples of external remote services and exploitation of remote services? Within the CyberX system, if you had NotPetya, you'd get an alert similar to this, right? And illegal SMB parameters, and essentially it's using part of the techniques associated here. And this is where you'd have initial access, lateral movement, and so forth. Next, you'd have remote file copy. And as the system started to spread within the environment, they spread, and we'd be able to detect that information with file transfers using like SMB as it's moving through your system. And then lastly, you have a tremendous loss of productivity and revenue. And this is the tactic, according to MITRE, called impact. And if we look at the impact for the top 6 firms, it ranged from over $120 million of impact from downtime to 870 million. So a tremendous amount of impact when we're looking at this particular malware. So what happened is this was fastly moving through the environment, and we can see that the initial access and lateral movement used external remote services. And these are some of the devices in where they would fit in the Purdue model, remote access, desktop systems, maybe there's phishing to get into the environment. And then from the remote access getting into your OT environment, where there was lateral movement and exploitation of remote services to compromise historian engineering stations, HMIs, and so forth. This is where it initially infected the IT network. It was a self-propagating worm, right, that used SMB version 1 vulnerabilities to spread, right, and it produced significant impact, as I mentioned before. And these are all of the timelines of what happened. But this happened in a matter of minutes once it happens into the OT network. And part of the reason is, in typical OT environment, there's really a lack of segmentation between levels 2 and 1 in the field level controls. So this is something that Industry 4.0 is highlighting and recommending different segmentation for some of the different levels within the Purdue model. There's another recent attack or a recent advisory, I should say. Cybersecurity Infrastructure Security Agency, along with NSA, produced this back in July of this year. And basically what they're saying is cyber actors have demonstrated willingness to conduct malicious cyber activity against critical infrastructure. And a couple of different things. Internet accessible OT assets are becoming more prevalent. So this is a trend that we're seeing industry-wide. You go to Shodan, for example, you can click a couple buttons and see what vendor PLCs are publicly accessible on the internet. And part of these legacy OT assets, they're not designed to handle the malicious cyber activities of the current environment, right? And this is part of this recommendation. So what do they say? They recommend create an accurate as-operated OT network map immediately. And then go in and catalog all your external connections to and from the OT network and determine specific risks associated with the OT devices. And then implement a continuous and vigilant system monitoring program with anomaly detection. So my challenge and question to you is, do you have an accurate as-operated OT map? And if you don't, how quickly would it be for you to build it? So remember a little bit earlier where we ran some PCAPs, and now what we're doing here is we see that I had a couple of assets to start with. Now I have 80 assets. And if I click a button, I see the map. This shows me maps by connections, and I can zoom in on any one of these different devices and quickly see who this person communicated with. Or if I want to relay out this map, a lot of times if we're talking to plant engineering and OT people, they want to lay out the map by the Purdue model. So let me just reorganize this thing. And you see right here, I'm zooming in a little bit, but now I have my supervisory level, my process control network right here. I have different devices that are associated with it. And if I click a button, I can see what those devices are. If I want more information, this happens to be an engineering workstation. It's a Windows 2012 server running SRTP, the IP address and the MAC and so forth. And if I want even more information to automatically categorize what some of these devices are doing, you can see here we break down the different protocols. So initially we had nothing. Now, if I want to highlight this in the overall map, you can see these 3 blue dots, and it shows me where these components are. And then I can even filter. So get rid of the noise and show me where the systems are. So now you can see part of the different information as it relates to these devices. If I'm interested in more of the industrial control system components that we have, and in this case, maybe I want to right click and view property information. And here you can see even the backplanes that are associated with some of the PLCs. So for example, this is a Rockwell system. I have a PLC here. I know the serial number that's associated with it. I know the version information, and I know that they have a couple of different slots. So in rack 1, slot 0, I have a communication adapter. And if I want to view this information, it's version 18.1, and I can view, this is interesting because there's 17 PLCs in back of it on a nested network. So if I click a button here, I can see the nested network, and maybe I want to get information on this PLC as well. So very quickly, you have the ability to see all of the information on a network map as recommended by this advisory, right? Create an accurate network map immediately, right? So now let's look at some of the, we already showed you some of the connections. And if we look at some of the risks that are associated with it, we can easily go in and create a risk assessment. So if I come here and I'm going to generate a report, and I'm going to come back to this in a bit, but we also have all of these alerts: unauthorized internet connectivity, excessive SMB login, a port scan. So I can click over here and understand what device is doing a port scan. When I click on, excuse me, this information, it immediately shows you the device and who is being port scanned. And if I want, I can even go back in and look at this information from an event timeline perspective. So if I look at the asset information and event timelines, then you can see this in more detail. So it takes me specifically right into when this particular PLC program was uploaded and so forth. So this is what they're talking about with identifying the risks associated with the devices and having a continuous monitoring program with anomaly detection. The next part of this advisory, it links it back into the MITRE ATT&CK framework. And it says, okay, here's some spear phishing, and these are the techniques that are being used. Commodity ransomware to encrypt the data, connected to internet PLCs with this tactic and so forth. When you have tactics and techniques, it's really important to help them be converged. And what do I mean by being converged? You really want to have a good SIM system to converge these attacks. In this particular example, I'm using Microsoft Azure Sentinel, and these are the CyberX alerts converged up into Sentinel. And you can see critical internet connectivity alerts. You can see SMB logins. You can see that port scan that I mentioned earlier on. And now, if you want to add additional information, the CyberX system also appends on the different tactics and techniques. So let's take a look at the specific ones that relate to the ICS framework, right? So the first part of it is right here, utilizing commonly used ports. So this is a specific technique associated with that. Now, in our particular case, we see commonly used ports right here. So this was part of the alerts that happened within our environment. Next, what happened is they used program downloads. So if we look to the advisory, here's what it's recommending, right? It's saying use of vendor engineering software with program downloads. So you can see we're following the specific trend of this particular attack. And then lastly, if we look over here at modifying the control logic, just like in that Triton attack, where they originally did a program download to embed their RAT, their remote access device inside so that they can control the PLC. So very similarly, we see the same level here for modifying the control logic, right? So this is how you can use CyberX and Sentinel to quickly understand what is the impact, partial loss and so forth, of having all the MITRE ATT&CK framework information consolidated in a SIM so that you can use the enterprise framework as well as the ICS framework. Okay, in the techniques matrix can really be used as a good threat hunting exercise, right? So you can map the alerts, and it's good for a tabletop or red team or blue team exercise. And here's the techniques matrix, right? In this particular example, you can see we have initial access, you can use command and control, inhibit response functions. So make sure that both teams know if your red team is starting to exercise, that your blue team has operational procedures that are associated with that. And this is why you want to consolidate this information in your SIM and SOAR platform. And I showed you earlier the Sentinel platform. Here's a Spunk version of that, right? With the same information. Here's your MITRE tactics and techniques. Here's the tactic, there's the technique, the titles that are associated with the CyberX, and then what protocols and the type. So it might be coming from our anomaly engine or a protocol or policy violation engine. So all of this information can be helped consolidated so that you can have your good operational procedures ready and active. Now let's look a little bit more complicated environment, and we'll look at the Triton attack. So within Triton, it was an attack on a petrochemical facility. As Phil mentioned, stole the OT credentials, deployed the PC malware, and got access into that PLC. And when they were doing the programming of the PLC, our Section 52 threat intelligence team reverse engineered this. And what they did was they identified with specially crafted framework within the Tri-Station protocol. And so if there was no identifier associated with it, it executed the original code. In this way, the perpetrators were able to be staying in the network for months before there was any notification of this. And how they did it was they used special opcodes. And here's the special identifier that said, if it's not, if there's no identifier, go execute the original program code. But if you have a special identifier, then it comes back. And in this case, in this particular packet, you see the special opcode right here. 17 means read memory. If I saw an opcode of 41, that would be write memory and change something on the PLC. If I wanted to execute something, I would use an F9 execution code. So you can see how the Tritonix protocol and the packet header and all of the details associated based on the reverse engineering that our CyberX Section 52 team did. So as we go through this, again, they wanted to disable the safety system and launch a second attack. Let's look at it from a MITRE ATT&CK framework now. And what you see here is all of the different techniques and tactics. And you can see early on, they did detection of program state. Is the PLC in program mode or run mode, right? Operating mode, control device identification. They got access to the engineering workstation. They did remote system discovery. They did lateral movement and command and control, exploitation for evasion. They did removal on the host, commonly used ports. They utilized and changed the operating mode of the PLC. They were masquerading when they had part of the Python scripts on the engineering workstation. And then scripting for firmware changes and things like that. So if you wanted to see what was going on, let's pretend that you're, and we'll go back to our Sentinel system here. Give me all PLC related alerts. What we can do is just simply filter on PLC. And you can see here I have PLC stop commands. And if I want any more details, I can simply go in. Oh, this was a Siemens S7 control that was a PLC stop. If you want information on maybe they were trying to modify the firmware, all I have to do now is just change this to firmware and rerun this query. So now what you see is there's some firmware, and there was some with persistence, right? My Honeywell firmware changed, for example, or GE command failure. right? So you have different information, and it's very easy to get quick access to this information, and you see all the different categories and techniques that were used and associated with that. All right, so this is how you can see how Triton and consolidating this information into your SIM can be very important. Here's, if you're interested in more technical details, I don't have to go in all the details because of the course of time, but go to this link and you'll see on this blog, and it goes into a tremendous amount of details. Here's all of the heat map, if you will, right, from the techniques matrix. And they, within Triton, they used 10 of 11 different tactics. And you can see all the ones. This is the only one that they didn't use within this particular malware. Okay. The other part that I want to highlight is that when you go through this, right, the attacks are becoming much more sophisticated, right? And you're going to need automation. And so Sentinel, and look at Sentinel Analytics, there's a lot of great automation in there as well, right? And here's 35 incident types, right, for that include automation. You see the tactics that are associated here with persistence, lateral movement, exfiltration, command and control, already built into some of the Sentinel functionality. In the next piece of this, you can also craft your own playbooks, right? So here's within Sentinel, you can craft a playbook and right under your analytics, and you tie these two together. So depending on the operational procedures, as I mentioned before, what are you going to do when somebody does changes of firmware? So when we have a firmware version change, shouldn't we validate that with the control engineer? And this is part of what you can do here. When you see those alerts, you create an incident, validate it with your PLC engineer, make sure that it's an authorized change. And in some cases, you have unauthorized devices on your network. So if you have unauthorized devices, maybe you want to implement something with like Power BI. So the data within the CyberX systems can be uplifted into Power BI. Here's a sample dashboard with total alerts, total devices. You can see alerts by device and by type, policy violations, and so forth. But maybe you have unauthorized devices in your network and you want to drill into detail. So I want to see where what is associated with this device. And you can see here it's an engineering workstation, and maybe you want to see what the CVE is that's associated with this engineering workstation. So you can easily and quickly get access to this information, but you have to be automated with this, right? So that's part of the keys. So automation and proactiveness. How do you be proactive? Remember earlier on, I wanted to click into this risk assessment report. So it was generated. Now I can click a button here and actually go in and see what it's telling me. So from a risk perspective, I'm at 41%. I definitely need to improve. I've got 37 vulnerable devices, 7 that need improvement. I've got 32 that are secure. And we want to also help you identify how to mitigate some of this information, right? So if I'm going to look to mitigate it, what are my recommendations? And CyberX will do not only security related, but also operational. And when you look at any alert over here, here's the security related information, unauthorized internet connectivity, port scanning, and so forth, and operational. So even if there's a Modbus exception, that's important to the plant engineer. A SIP request failed, right? This is where the programming is incorrect, right? So this will help the operational component. And over here, maybe you need to upgrade the firmware in order to get 12% impact on your security score. All right, so this is where you can really see some good information. And then you have all the details of the devices as well. So here's like a specific device of Rockwell and the security and CVEs that are associated with that device. And we also take into account unacknowledged alerts that are associated with this. So this is what we mean to be proactive, right? Understand your risks. Next is, if somebody were to try to compromise your environment, how would they go about doing it? So in the case of our environment here, what I want to do is simulate an attack, right? So let me go in, here's an attack simulation. I want to look at it from all devices to all the targets. And so based on, remember we had 0 devices earlier on, based on the connectivity of those devices and what CVEs are known, how would an attacker compromise my environment? So you can see here I have internet connectivity to a historian. There's a known CVE on this historian. From there, I can pivot to an engineering workstation, right? There's a known CVE to my next device, which is my PLC to my Rockwell controller. So here you can see how you could compromise the environment and if there are any alerts associated with this right now. So if I went into my alerts and I look at maybe an advanced filter on the group from my Engineering West workstation, confirm the filters, I've already got these devices. There's a port scan, a SIP request failed, and a protocol command failure, just with the devices that have been monitored right now. So this way you can help you before they can reprogram the PLCs. All right, next, here's kind of the summary and recommendations. Let's try to create a company-wide culture of OT security, right? Let's not be a careless user, for example, where you plug in your laptop or USB into unused ports, where you're going to share VPN credentials with third-party vendors, where you're doing unauthorized connections between IT and OT. And if we look at unauthorized connections, essentially, if I look at my asset map, I can see over here cross subnet connections. So these are devices that are going between different networks, right? And so we want to make sure between IT and OT, we don't have those, right? If we want to install unauthorized wireless access points, or if we have dual home PCs for convenience. So early detection is critical. Monitor remote access more than ever. These are all of the different types of commands, SSH, Telnet, and so forth. You can see over here remote desktop connections. So it's easily obtainable. And then when you click in this device, make sure your remote access isn't talking to all the other devices on your network, right? Identify where they are in the kill chain. And so here is the kill chain example. Remember all the different components. Identify this early, but make sure you have a historical view so you can see where these alerts line up and get a PCAP of that alert so you could see if this programming of the PLC was valid or if there's malware inside of that as well. So Phil, I'd like to turn it back over to you to wrap up.
Thanks, Joe. And that was a lot of material in a short amount of time, but I'm sure the group really appreciated it. And I just want to let you know that there are a number of places you can go to get more information. Ignite is next week, so be sure to check in and listen to our 30-minute on-demand session where we're going to go into more details about the Sentinel integration. And then we have a SANS webinar coming up on October 6th, which will be featuring the folks at Microsoft that are using this technology to secure the building automation systems in Azure. And for some reason, I'm not sure this is being displayed. Let's see. Okay, there we go. Nope, that was wrong. Sorry, I did the wrong thing. Let's try this again. Okay, so here are a number of places you can go to get more information. And we're right at the top of the hour, so I'm going to see my slide. For some reason, you're not seeing my slide. Joe, are you seeing my slide about learn
So
more?
you're good. It's not in presentation mode, but you're good. Yeah.
Okay, great, thanks. So I encourage you to go look at, we have some interesting white papers on Triton, some more stuff about living off the land, some NIST, and white paper on MITRE as well, and Zero Trust, which is a very hot topic. And yeah, just to wrap up, I want to thank you for joining us, and I'm going to hand it back to Bellon.
Thank you so much. Just some reminders for the folks who are following us and are interested to join our next scheduled security webinars. I'll just post the link here at the aka.ms/security webinars. Just do that right here. And In case we missed, although Phil here answered plenty of questions, and thank you for the questions, but in case we missed to answer your questions, or if you have additional questions, you can visit us on Microsoft Security and Compliance Forum. The link is aka.ms/MS Security Compliance. And I would like to close this webinar by thanking Phil and Joe for an excellent presentation. And most of all, I want to thank all of you for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.
Thanks, everyone.